A SQL join is the reason that you could put a beam on a gen or an FRT on a Draco. To understand this, twin, you gotta know what a join is. A join combines rows from two or more tables based on a related column. And when joining tables, we use the on clause to compare rows and determine how they match. And it's common in the on clause to match a primary key of one table to the foreign key of another, but that's not always the case. But we basically will compare those rows. If that comparison uses an equal, then that's called an equal join. But if it uses anything else like a less than or greater than, then that's called a non-equal join. And when comparing rows, the values being compared, they gotta have the same data type. When talking about joins, one of the most important parts is the on clause. Most of them have one, but not all of them do. Just like the first one we're gonna talk about, which is the cross join or the Cartesian product. So a cross join, aka the Cartesian product, basically returns a table with every possible combination of rows from two or more tables. It sounds difficult, but it's not, twin, and I can merge it. So let's look at this example real quick. So we have two tables, one with blicks in it and one with attachments. And we want to find what do we get if every blick is paired with every attachment, aka a cross join. For our blicks, we have a Gen 5 and we have a Draco. For our attachments, we have a base, a beam, and a force reset trigger. And a Gen 5 is a Glock. If you know, you know. So for our Gen 5, if we want every combination, we can go with the base, which means nothing on it. We can go with the beam on it. And we could go with the force reset trigger, the FRT. For our Draco, we could do the same. We can have a Draco that's base, nothing on it. We can have Draco with a beam. We have a Draco with a force reset trigger. And that's a cross joint. You see in the table, we have everyone in there. And we can add a little aggregate function on the end if you want to get the total price with the attachments. And don't ask me why these blicks are so cheap. Somebody probably caught their first hat with it. And just like a Gen or just like a Draco, cross joints could be dangerous because how fast they grow. Now let's talk about an inner join. An inner join only returns rows that match in the left and the right table. This means whatever related column that you're joining these tables on, that you can't have a null in that column. In this example, we have two tables for a trap house. We have one table with the customer ID and the name. We have one with the visit ID, customer ID, and the visit date. If we inner join these tables on the customer ID, we can find out who visited the trap house and on what day. And remember, inner, we're looking for matches. So since we're joining on the ID, if both tables don't have the ID, and it's going to be left out of the result. And looking at this, we see customer ID 1, 2, and 3 is in both tables. That means that Slim, Jordan, and Alex, they visited the trap house and they're going to be in the final result. We also have another customer ID 5, which is not in both tables. So that means that they're not going to be in the final result. And I don't know how to feel about that since they're not in the name table. And I think I seen customer 5 with a wire when he came to the trap. So pop, El Wiro. And that's why we see 3 rows in this table, even though the trap had 4 visits. Now we have the full join, aka the full outer join. And this returns all the rows from both tables, matched or not matched. And when using this type of join, it's common to have a null or multiple nulls. For this example, we're going to be using the trap house again. So we have our first table with the customer ID and the name, and we have our second table with the visit ID, customer ID, and the visit date. And when we full join these on the customer ID, you see 1, 2, and 3, those customer IDs are in the first table. So in the result, their name is going to be there with the date that they visited. But remember, ID 5 is not in the first table. Customer ID 5 is in the second table, but it's not in the first. But since this is a full join, we're going to put it in the result regardless. So in the name column, it's just going to be null and with the visit date whenever they came. And now we get to do the left join. And I can merge, this is one of my favorite joins. When it comes to a left join, we return all the rows from the left table and only the matching rows from the right table. And if the right table can't find a match, we're going to put a no there. In this example, we have 2 tables, one with the ID and the name, and we have one with the job ID, the ID, and the job. And if we do a left join on the ID column in the first table and the second table, then we can find out who does what job. We see ID 1, 3, and 4 in the left table did find a match with the right table. And we see that ID number 3 is in there twice. That means AK is a hustler. I don't know who AK is, but y'all should be more like him because I think he got motion. But we see AK's ID 3 is in there twice for 2 jobs, a producer and a software engineer. So that means that he's going to be in the result twice. You see John is in the left table, but he's not in the right table. So he's still going to be in the result, but for his job, it's just going to be null because it's not in the right table. Now we can talk about the right join, and it's just the opposite of the left join. So all the right rows are going to be there regardless, and we want to find the match in the left table, and if we don't, it's just going to be null. And for this example, we're going to use the same tables, but we're going to switch up the data just a little bit. So we got the first one with the ID and the name, then we have the other one with the job ID, and the job, which is going to be our right table. And we already know, since it's a right table and it's a right join, all these jobs are going to be there regardless, no matter what. We're joining this on ID, and we see ID 1, 4, and 3 are in both tables, so we know that they're going to find a match. The names associated with those IDs are going to be there with whatever job they got. We have Chris there, we have Mark, and we have AK there with their jobs. AK lost his job, I guess, from the last example, but it's cool. In the right table, we have ID 5, which is our street pharmacist, and that ID is not in our first table. So we're going to have our street pharmacist there regardless, but the name is going to be null because our right table with the street pharmacist cannot find a match in the first table. And by first table, I mean the left table. In today's video, we covered the inner join, the full join, the left join, the right join, and the cross join. And I hope you guys understand this just a little bit better. And if you enjoyed the video, please leave a comment. It really does mean a lot. And I'll see you on the next video, twin.